In this question, it is given that water is flowing through a horizontal pipe of varying cross section. If pressure of water equals to 2 centimeter of mercury, where the velocity flow is 32 meter per centimeter per second, what is the pressure at another point where the velocity of flow is 65 centimeter per second? So we are considering a horizontal pipe. So we can write for this horizontal pipe the gravitational potential will be same. So for one particular point, take it as area of cross section is A1, and for the other point, take it as area of cross section is A2. And liquid is flowing with a velocity, take it as over here, it is flowing with a velocity 32 centimeter per second. This 32 centimeter per second, if we are converting into meter per second, we can write 0.32 meter per second. And on the other point, liquid is flowing with a velocity that is equal to 0.65 centimeter per second. Then Rm is to, let's say, find out consider that pressure over here, P1, which is given as something but 2 centimeter of mercury, and pressure over here, Rm is to find out the value of pressure over here. Let's say that is equal to P2. Now we know that where the value of pressure is more, the value of the value of pressure will be, where the value of velocity is more, there the value of pressure will be less. So this value of P2 is anyway which is going to be less than that of 2. Now we can write Bernoulli's theorem between these 2 points. So we can write pressure at point 1 plus half into rho into V1 square is equal to, over here the gravitational potential energy is same, that's why I'm not going to write it. Anyway, they are going to get cancelled. So P2 plus half into rho into V2 square. So Rm is to find out the value of P2, which can be written as P1 plus half into rho into V1 square minus V2 square. Now we can just put the value over here. So P2 is equal to P1, which we know that that is equal to 2 atmospheric pressure. So it is P1, that is 2 centimeter of mercury plus half into rho is nothing but density of water. We can take it as 10 raised to 3 in a size system, and the value of V1 square, the value of V1 is nothing but 0.32 the whole square minus V2 is 0.65 the whole square. So we can write the value of P2 is equal to nothing but P1 plus, this is half into 10 raised to 3 into 0.32 square, this is around 0.1024 minus the value of 0.65 square is going to be 0.4225. So if you're subtracting this, we'll get the answer for it, that is around half into 10 raised to 3 into, if you're calculating it, so you'll get around minus 0.3201 divided by 2 into 100, then we'll get its value as around 0.16 into 10 raised to 3. So over here, this 0.16 into 10 raised to 3 is, anyway, this is going to be a negative value. So you can write P1 minus this. So this 0.16 into 10 raised to 3 is the value in SI system. That means its value in Pascal. Now we can use that, but in question they are giving the answer in terms of centimeter of mercury. So the equation for pressure is H into rho into G, where H is the height of liquid column and rho is density of liquid, and G is nothing but acceleration due to gravity. So we can find out what about 0.16 into 10 raised to 3 Pascal in terms of height of mercury column. Let's say that is equal to H height of mercury column, or equal to pressure exerted by H height of mercury column. And pressure exerted by the liquid is H into rho into G. H into density of mercury is 13.6 into 10 raised to 3 into acceleration due to gravity, we can take it as 10. So we can find out the value of H, that is 0.16 into 10 raised to 3 divided by 13.6 into 10 raised to 4. So if you are calculating it, you'll get the value as around 0.001176 something. This much in meter. But in option they are given in terms of centimeter, so we can write centimeter is going to be approximately 0.11 centimeter. So we can just put this value over here. So the value of pressure P2 will be equal to P1 minus the value of pressure which is in centimeter of mercury, that is 0.11 centimeter of mercury. The value of P1 is given as nothing but 2 minus 0.11 centimeter, we can write that is equal to around 1.89 centimeter, or approximately we can write as 1.8.